The consumer interface represents an operation that takes a single argument and doesn't return a value. Now, why does this matter? Why do you have to learn about the consumer interface? Well, a lot of methods in Java expect an object that implements the consumer interface. I will show you an example of this later in this video. But first, let's look at the methods of this interface. So, as you can see, here we have a single abstract method called accept that takes an argument of type t, and here t is our generic type parameter, and this method doesn't return a value. We also have a default method. As I told you before, these default methods have an implementation. I'm going to talk about this method in the next video. So the consumer interface represents an operation that takes a single argument and doesn't return a value. Now we have a few variations of this interface. One of them is by consumer that takes two arguments. So if you look at the accept method, you can see here we have two arguments, t and u. We also have int consumer. This is one of the primitive specializations of this interface. So the accept method takes a primitive integer. So if you're dealing with a lot of integer values, it is more efficient to use this interface as opposed to the regular consumer interface. Because with this interface, you don't pay the cost of auto boxing. We also have long consumer and double consumer. Now let me show you how to use the consumer interface. I'm going to create a list of integers. And here I'm going to use list of to initialize this list with a few items. So 1, 2, and 3. Now there are two ways to iterate over this list. We can use a for each loop. So for each item in list, print each item. Now there is another way to iterate over this list. We can call list.forEach and take a look. This method expects a consumer object. In fact, a consumer of integer. As you saw, the consumer interface is a functional interface because it has a single abstract method. So we can represent it using a lambda expression. In this case, we want to pass a lambda expression that takes an integer and doesn't return a value. So let's pass a lambda expression here. First, we add the parameter, integer, item. Then the lambda operator that goes to a code block. Now, in this case, we don't really need to specify the type of this parameter because the Java compiler knows that every item in this list is an instance of the integer class. So this type is redundant. Let's remove it. Now we have a single parameter, so we can get rid of the parentheses. That is better. Now, in the body of this lambda, I just want to print this item. Because we have a single statement, we don't even need the code block. So print item. So these are two different ways to iterate over a list. What we have on the top is an example of imperative programming. That basically means implementing logic using instructions. For example, whenever we have for loops or if and else statements or switch and case, we are writing code in imperative style. So imperative programming is a style of programming or a programming paradigm. Now, we have so many different programming paradigms or styles of programming like functional, object-oriented, event-driven, and so on. What we have on the bottom is an example of declarative programming. So instead of using instructions to specify how something should be done, we specify what needs to be done. So here we don't have a for statement. We're simply saying for each item in this list, print it. Now we're going to talk more about this concept. So if this is new to you, don't worry. Next, we're going to talk about chaining consumers.